another example. So if we have 2xy dx plus x squared minus 1 dy equals 0. So in this section, we always write our equation in this form. The left side is a function, we call it m times dx, plus another function called m times dy, and equals 0. So this is a first order differential equation, but may not be linear. Okay. All right, so what we need to do first is to check if this is the exact equation. If it is, we can use this method. So let's verify this is. So partial m over partial y, so equals, treat y as variable, x as constant, so we get 2x. And we do partial n over partial x, with respect to x, so we get 2x. And they are equal to each other. So this is an exact equation, exact differential equation. So what we can do is to try to find out, well, what's the, in this case, we only know the two functions here. That we know the left side is the differential of some two variable function, but what is this two variable function? So we need to find it out. Okay, so if we recall the formula is right here. So let me rewrite the formula. So if we have a two variable function z, the differential of z is partial z over partial x times dx plus partial z over partial y times dy. So if we compare the left side, let me copy down the left side, 2xy dx plus x squared minus y times dy. Compare them. So that means partial z over partial x equals 2xy. So identify them. We get partial z over partial x equals 2xy. And partial z over partial y, these two, identify them, we get equals x squared minus y. So now we need to figure out what this z function is. Okay, so it's kind of like sort of like doing antiderivative. So we look at the first partial differential equation. We try to figure out part of z. We may not be able to figure out z in one step. So this is a derivative of some function with respect to x. So we're going to take integration with respect to x. See if I write this down, will be with respect to x. So remember to treat y as a constant. So if y is a constant like 2, I can pull them out. I get 2y and find antiderivative of x. So antiderivative of x is half of x squared. Okay, so we get, cancel 1/2 and 2. We get a function x squared y. And plus, well, usually we have, when we take antiderivative, we know there's a constant with plus c. But here, actually, it's not a constant. It's a function of y. Because with respect to x, any function of y is considered as a constant. So that is constant in this case. It's different from one variable function. Because when we take the derivative, anything, if it only has y, the derivative will be 0. So it's like a constant with respect to x. So that's why we have a function of g of y instead of just a constant c. Okay, so here we kind of figure out z, part of z, but we know it has x squared y, but we still have another part, a function. This is unknown. We don't know. We use the letter g to denote this unknown function. We still have to figure it out. So now I'm going to use the second part to figure out what g of y is. So I already figured out z, part of z, so I can plug in here. I plug into the second function. So when we have this function, we take the derivative with respect to y. So with respect to y, so x squared will be considered as a constant. And so when we take the derivative of this part, it's going to be x squared. Plus, so I'm working on the left side, partial z over partial y. The left side will be derivative. So this means the derivative of z with respect to y. So we're going to treat y as a variable, x as constant. So that's why the derivative of x squared, y is equal to x squared. And the derivative of gy, we don't know what g of y is, so I have to just write it down, derivative of g of y. Okay, that's the left side. And the right side just copied x squared minus 1. So now we can see, so I just copied the left side and the right side. The left side is what we get from plugging in, or you can take in the derivative of this function z here. Now we can subtract x squared from both sides. We get g prime of y equals -1. So that's like, we know the derivative of a function of y is 1. How do we find out the function? So we can integrate both sides with respect to y, because the variable is y in here. So the left side, derivative and antiderivative, so it's g of y, the original function. Antiderivative of derivative function is itself. And then the right side, we get -y. So be careful, because the variable is y, so that's why we get y instead of x. And plus constant c. Okay, so now we get our z function. Well, I guess it's not necessary to use c here, because we will get another c later. We can combine it. So let me show you why we don't use constant here. So if I call it this c1, so I get my z function. Combine these two. Plug g of y back in z function. X squared y minus y plus c1. So this is our z function. Now let's go back to original problem. The whole left side, we found out the whole left side can be written as a differential of this z function. I copy z function, x squared y minus y plus c1 equals 0. And now I can integrate both sides. I will get x squared y minus y plus c1. And the right side, it's another constant. So now we can combine c2 and c1, subtract c1 both sides. We can call c2, c1 a variable c. So that's why actually it's not necessary to have the c1 here. We can just go ahead and use x squared y minus 1 minus y. And then we just get one constant. So what we can do is simply use x squared y minus y and equals 0. And so the left side will be x after integrating, and the right side will be constant. So we can use this directly. Okay, so let's go over this example again. This method only applies to exact differential equation. So first of all, we have to verify. So the step 1, verify by using this criteria. Take the coefficient of dx, the function in front of dx. Take the derivative with respect to y. And then take the derivative of the function in front of y with respect to x. Now verify they're equal. After that, we need to figure out, by using the differential formula, to figure out what z is. The example we had at the very beginning, we were given z. Z was given. Z is x squared minus 5xy plus y cubed. So what we did was to take partial derivative of z, partial derivative with respect to x, with respect to y, and plug into this formula here, differential formula. But now in this section, we need to go backwards. We know the differential. So we know this answer, 2x minus y times dx plus -5x plus 3y squared times dy. But we don't know this z function, so we kind of have to go backwards. When we go backwards, it's like doing antiderivative. Because when we start with z, we do derivatives, treating one of them as a variable, the other as a constant. So when we go backwards, we do antiderivative, still treating one of them as a variable, the other as a constant. So this might be something new here, treating y or treating x as a constant or the other as variable. So that's after we found out the z function, it's going to be very easy. Step 3. So the left side will be the differential. And we can verify this very easily. The left side, if you take the differential, using the differential formula, we will get exactly 2xy dx plus x squared minus 1 dy equals 0. So that's how we solve this type of equation. Compared to linear equation, we always write it in the standard form, and we have a formula to find out integrating factor and multiply integrating factor to make the left side the derivative of a product. Here we make the left side the differential of two variable function. So the left side we usually keep it like this format: something times dx plus something times dy. Okay, so let's look at another example.